questions 1 through 10 on the 2012 grade 12 AMC 12B. Each third grade classroom at Pearl Creek Elementary has 18 students and 2 pet rabbits. How many more students than rabbits are there in all 4 of the third grade classrooms? Well, there's 4 classrooms, so there's 4 times 18 students, and that is 72. And there's 4 classrooms, and each has 2 pet rabbits, so that's 8. And they want you to compare 72 to 8. 72 minus 8 is 64. So there's 64 more students than there are rabbits if you look at all 4 classrooms combined. So number 1, the answer is C. A circle of radius 5 is inscribed in a rectangle as shown. The ratio of the length of the rectangle to its width is 2 to 1. What is the area of the rectangle? Well, the first thing we can do is drop a top to bottom radius. Actually, it would be the diameter. And since the radius is 5, that diameter is 10. So this is 10, this is 10. And then they told me that the length is twice the width, right? The ratio is 2 to 1. So that means the length is 20. So the area of the rectangle is length times width, and therefore that's 20 times 10, which is 200. So number 2, the answer is E. For a science project, Sammy observed a chipmunk and a squirrel stashing acorns in holes. The chipmunk hid 3 acorns in each of the holes it dug. The squirrel hid 4 acorns in each of the holes it dug. They each hid the same number of acorns, although the squirrel needed 4 fewer holes. How many acorns did the chipmunk hide? So we have a chipmunk and we have a squirrel, and both of them have the same number of acorns. Now the number of holes that the chipmunk makes is the number of acorns. Acon is a singer. Acon. Keep saying this. I believe this is a singer, but that's not the question. Acorns is A divided by 3 for the chipmunk, and then for the squirrel, the number of holes he makes is A divided by 4. And what they have told us in the question is that HC, the number of holes the chipmunk makes, compared to the number of holes that the squirrel makes, is that HC is equal to HS plus 4. Because the squirrel needed 4 fewer holes. So now we just equate. This is A over 3, and this is A over 4, and that's it. So then I guess we just have to do the math here. So this becomes A over 3 minus A over 4 is equal to 4. 4, 4, 3, 3, and this is going to be A over 12 is equal to 4, and therefore A is equal to 48. And that is the number of acorns that the chipmunk hid. So number 3, the answer is D. Suppose that the euro is worth $1.3. If Diana had $500 and Étienne had 400 euros, by what percent is the value of Étienne's money greater than the value of Diana's money? Well, we want Étienne over Diana, the ratio, and that is 400 euros over 500 US dollars. And 400, therefore, you multiply by 1.3, and this stays 500. We're just going to do a dollar-to-dollar comparison. 400 times 1.3 is 520 over 500, and therefore divide top and bottom by 5, and you'll get 104 over 100. And as you can clearly see, that ratio is showing that Étienne is 4% greater. So number 4, the answer is B. 2 integers have a sum of 26. When 2 more integers are added to the first 2, the sum is 41. Finally, when 2 more integers are added to the sum of the previous 4, the sum is 57. What is the minimum number of even integers among the 6 integers? A plus B is 26, and then you're adding 2 more to that list to get 41. So therefore, C plus D obviously must be equal to 15. And then we're taking this list and adding 2 more yet again, and that is E plus F, and that is 57. Now these 4 guys were 41, so that means E plus F must be 16. Yeah. So now what we want to do is choose values for A, B, C, D, E, F, such that we don't choose even numbers if possible, because we want the minimum number of even numbers for those 6. Okay, well, for A and B, I think we can do it with just odd numbers, 13 plus 13, for example. So we don't choose any even there. For 15, there's no way to choose 2 odd. There has to be 1 even. So for example, 9 and 6. There has to be 1 even in there in order for the sum to be 15. And then for 16, we can choose 2 odd. We can choose, for example, 9 and 7. So I did this in a way so that the minimum number of even numbers were used. And how many even numbers did I use? Just 1. 6 was the only one that was even among the 6. So number 5, the answer is A. In order to estimate the value of x minus y, where x and y are real numbers with x greater than y and greater than 0, Zhao Li rounded x up by a small amount and rounded y down by the same amount. Then subtracted her rounded values. Which of the following statements is necessarily correct? We have x, y, and let's give some values, make it easier. Let's just say x is 9.9 and y is 5.1. And then when we round x up by a small amount, we'll round it up to 10. We'll round it up by 0.1. Round y down by the same amount becomes 5. And now we have to figure out what are the differences. So the actual difference of the actual numbers, x minus y, is 9.9 minus 5.1, which is 4.8. But the estimate, which is what she is going to get with these rounded numbers, is 10 minus 5, which is 5. So they're saying compare the estimate to the actual value. Well, looking at these two numbers, you can clearly see that the estimate is greater than the actual value of x minus y. So that means number 6, the answer is A. Small lights are hung on a string 6 inches apart in the order red, red, green, 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 red, red, green, 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 and so on, counting this pattern of 2 red lights followed by 3 green lights. How many feet separate the 3rd red light and the 21st red light? Note 1 foot is equal to 12 inches. We have a pattern of red, red, then green, 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 then red, red, and then green, 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 and so on, right? So what I'll do is I'll just write it out until I hit the 21st red light. So here we go. The 3rd red light is right here. And the 21st red light is right here. So they want you to figure out the distance. Well, the distance between 2 lights is 6 inches, so we have to count how many. Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is all in a row. I couldn't write it in a row. Then we have all of these guys, which is, of course, 15. And then you have another 15. And then you have 1, 2, 3, 4, 5, 6. So adding these up, you get 39, 45. So from this guy, which is the 3rd red light, to this guy, which is the 21st red light, we have to go 45 lights. And each light that we move forward is 6 inches, which is half a foot. So the distance would be 45 times a half, which is 22.5. And therefore, number 7, the answer is E. A dessert chef prepares the dessert for every day of the week, starting with Sunday. The dessert each day is either cake, pie, ice cream, or pudding. The same dessert may not be served 2 days in a row. There must be cake on Friday because of a birthday. How many different dessert menus for the week are possible? We have 7 days for this week, of course, and Friday has to be a cake, and this is Sunday, Monday, and so on. Now, the clause in this question is that the same dessert may not be served 2 days in a row. So, for example, on Sunday, we can put any of the possible choices. There's 4 of them. So, for example, if cake is served on Friday, then on Saturday we can not serve cake, but we can serve the other 3, either pie, ice cream, or pudding. So we got 3 choices. Very similarly, on Thursday, we can't serve the cake because we can't have 2 things that are the same 2 days in a row, but we can serve any of the other 3. On Thursday, if you serve, let's say, pie, on Wednesday you can serve the other 3 possibilities, cake, ice cream, or pudding. So 3. And it just kind of keeps going like that. So on Monday, if you served pie, on Sunday you can serve anything except pie, which is 3. So that's pretty much all it is. Doesn't have to be any more confusing than that. So you just multiply these, 3 times 3 all the way across, and this is just fixed as a 1 choice. So this just is 3 to the power of 6, right? 9 times 9 times 9, which is 729. So number 8, the answer is A. It takes Cayley 60 seconds to walk down an escalator when it is not operating, and only 24 seconds to walk down the escalator when it is operating. How many seconds does it take Cayley to ride down the operating escalator when she just stands on it? Speed is equal to distance over time is the formula we will use in this question. And the speed of her, Cayley, is distance over time, in this case is 60 seconds. And then when she is moving along with the escalator, her speed plus the speed of the escalator together result in obviously a faster time, and that's 24 seconds. So our task in this question is to find the speed of the escalator, SE. Okay, so I guess we just work with this formula right here. SC is d over 60, and then SE, and d over 24. So SE, which is the speed of the escalator, is d over 24 minus d over 60, and then we just have to subtract this fraction, 2, 2, 5, 5, and you get 5d minus 2d over 120, and that is 3d over 120. And in lowest terms, that's d over 40. So SE is d over 40. Basically what that means is to go down the distance of the escalator takes 40 seconds. So number 9, the answer is B. What is the area of the polygon whose vertices are the points of intersection of the curves x squared plus y squared is 25 and x minus 4 squared plus 9y squared is 81? So first of all, what is this? What are these equations? Well, the first one I can see is a circle. This one right here. That's a circle of radius 5. So that one is something like this, right? And if you recall, circles have the equation x minus h squared plus y minus k squared is equal to r squared, where hk is the center and r is the radius, obviously. But in this case, there is no hk. It's just x squared plus y squared, so that means the center is 0 right here. And then the radius is 5, so this is 5, and this is negative 5, and so on. But what about the next one? The next one is a little bit different. You got this 9 in here, so that makes it not a circle. If it's not a circle, well, what is it then? It is an ellipse. And that is the story of this question. So our task is to find, first of all, the shape that's created by the intersection points. And the intersection points, clearly you can see, are here, here, and here. And when you join them, it creates a triangle. So I don't know why they didn't say triangle, why they used the word polygon. Makes it unnecessarily more confusing. So our task is basically to find the area of that triangle. Okay, shouldn't be too problematic. Area is 1/2 base times height. This is the base, and we can use that as the height. So all we really need is 1 point, and if we get that, we can figure out the base and the height. Okay, so how do we figure out that? These are two equations are intersecting, so we have to equate them equal to each other. So the first one, I will isolate for y squared. It'll be 25 minus x squared. And then substitute that into the second equation. So x minus 4 squared plus 9 times y squared, which is 25 minus x squared. And that is equal to 81. All right, no tricks, just straight algebra. So we got x squared minus 8x plus 16. And this is 225 minus 9x squared is equal to 81. Let's put everything on one side. If we do, we get, let's see here, minus 8x squared minus 8x plus 160 is equal to 0. And then, of course, divide through by negative 8. X squared plus x minus 20. And I think this will factor the x 4, 5, positive, negative. Yeah. So that means x is equal to 4 or negative 5. Well, obviously, let's see here. Yeah, that works out perfectly. So what we need is this point that I drew the arrow. So that's going to be obviously 4 for the x-coordinate. And the y-coordinate we can get just by substituting back into any of these. So y squared is 25 minus 16 because x is 4. So y squared is 9, and that means y is equal to plus or minus 3. So this is plus 3, and this would be 4, negative 3, that point right there, this one. So we can do the area pretty quickly now. The base is 6, right? Going up by 3, going down by 3. And then the height, or the distance from there to there, well, the distance from the origin to there is 4. The distance from the origin to there is 5. So 4 plus 5 is 9. So we have 6 times 9 divided by 2, which is 27. And that is the area. Number 10, therefore, is B.